A raffle offers a first prize of $1,000, 2 second prizes of $300, and 20 third prizes of $10 each. If 1,000 tickets are sold at 50 cents each, find the expected winnings for a person buying one ticket. Now this is similar to the one we just worked, but it's slightly more complicated because there are more prizes. As before, I'm going to let X be the expected winnings. But instead of there being only 2 things that can happen in this lottery, there are actually 4 things that can happen. First of all, you could lose. And if you lose, all you lose is the 50 cents you put in. So 50 cents is $0.5. You lose 50 cents. However, you can win third prize, which is $10. But again, you paid 50 cents for the ticket, so technically you didn't win $10, you won $9.50. Or you could win second place. Again, the second place is $300, but technically it cost you 50 cents for the tickets. You really only won $299.50. Or you could win first place, which is $1,000. Again, technically you only won $999.50 because it cost you 50 cents for the ticket. Now, if you use that information and set up your PDF, here's what it would look like. If you lose the 50 cents you put in. If you win third place, you win $10 minus the 50 cents you paid. If you win second place, you win $300 minus the 50 cents you paid for the ticket. And if you win first place, you win $1,000 minus the 50 cents. Now, there's only one winning ticket for first place. That's 1 out of 1,000. So the probability of winning first place is 1 out of 1,000. However, there are 2 second place tickets, so there's 2 chances out of 1,000 of winning second place. And there are lots of third place tickets. There are actually 20 of them. So there's 20 chances out of 1,000 to win third place. And the rest of them are losers. If you say 20 plus 2 plus 3, that's 23. 23 winners. The rest of them lose. So 1,000 minus 23 is 977. So 977 out of 1,000 of the tickets are losers. So there's your PDF. You can make another row that takes that product, that product, that product, that product, and add them all up. You can do it that way. It works. However, in my opinion, these calculations are rather involved. In other words, the numbers aren't really nice and there are lots of them. If you want to continue along that route, if you do it correctly, you'll get the right answer. But I'm going to suggest a different way if the numbers get kind of messy. Okay? Here's my suggestion. If the numbers are sort of messy, try a different way. Ignore the cost of the ticket until the end. In other words, just pretend that the ticket didn't even cost you anything. And work the problem as if the ticket didn't cost anything, and then when you're finished with your answer, subtract the cost of the ticket at the end. It will give you exactly the same answer, and I promise you the arithmetic is much easier. So my suggestion, and you don't have to take it, is to temporarily ignore the cost of the ticket and rewrite the PDF so that the ticket's not calculated in there anymore. So instead of having a negative 0.5 for the price of the ticket if you lose, just pretend for a minute the ticket didn't cost you anything. Then you really did win nothing if you lose. You won $10 if you got third place, you won $300 if you got second place, and you won $1,000 if you got first place, and the probabilities stay the same. This simplifies matters because this pretends that the ticket didn't cost you anything. But the nice thing is these numbers are a lot nicer. So if you take the product and make a new row, well, let's do that right now, you'll see that the arithmetic is so much nicer. If we make another row for the product of x and p of x, we get 0 times anything is 0. 10 times 20 is 200 over 1,000. 3 times 2 is 600 over 1,000. And 1,000 times 1 is 1,000 over 1,000. That's really just 1, but I'm going to go ahead and write it this way. So the expected value is the sum of those products. So let's move this up a little bit. So the expected value of x is 0 plus 200 1,000ths plus 600 1,000ths plus 1,000 1,000ths. You've got a zero, you forget the zero, and you've got a common denominator, so you just add the numerators. That's 200 plus 600 is 800 plus 1,000, that's 1,800 over 1,000. Now if you do that on the calculator, or if you can do it in your head, that comes out to be, let's see if I can do a better dollar sign this time, $1.80. So your expected winnings is $1.80. But remember, the ticket really wasn't free. We pretended it was free. If the ticket really cost 50 cents, so the expected value is really what we found a minute ago, $1.80 minus the cost of the ticket, which is $1.30. So your expected winnings are really $1.30. Now notice that was kind of a trick, but it works. It makes the arithmetic easier. So if you want to forget about the cost of the ticket until the very end, you can do it that way. And in this case, I would highly recommend it. The other problem I worked, there wasn't a whole lot of difference. I didn't bother. But it works all the time. It's just a matter of how you'd rather do it.